Can everybody hear me okay at the back? Yeah, great. I'm always not used to wearing these mics. I feel like Justin Bieber. Maybe I should go to the Estonia Song Festival next year. Maybe this would help a little bit. Okay, so I'm going to go through test automation in Python. It's glad to see that quite a few people there put their hands up to using Python. I'm Kyle McEvoy. I'm the director of QA at a company called FanDuel. You can follow me on Twitter. It's not really a nice, easy one to remember, but _KMCE. Please do follow me. And I want to say thank you very much to Nordic Testing Days. This is my first conference talk. Really, thank you very much for the opportunity. For those who don't know who FanDuel is, we are an American-Scottish company. We deal with fantasy football. The traditional way of doing fantasy football is like a season-long game. You play with your friends, you draft your favorite players, and you compete against each other. We change that to a daily format, so you can play against your friends and settle a contest within a day or a weekend. We are hiring. So please, if you're interested in either moving to somewhere like New York or Edinburgh or Glasgow in Scotland, please do check that out. It's not just for testers as well, all sorts, project marketing, all sorts. So hopefully just going to go through some various things, just generally kind of give you an overview of what Python has to offer for test automation in general, some general use case examples, and we'll just kind of end it with a quick fire session of like lessons learned. One thing I'm slightly conscious of is there are some code examples, and I think for the most part it should be very relatively straightforward to see. It might be slightly difficult on those smaller screens, but hopefully it shouldn't be too bad. So how's all me to it? You've already said people have done automation before. Is there anyone who's not done automation in Python that they're new, that they're looking to learn? That's good. Okay, so hopefully this will satisfy what you need. On Stack Overflow, there was a report done, and it was kind of looking into the amount of questions that were tagged with Python or that had been viewed for Python. And there's considerable sort of growth going up until 2018. They did some statistical analysis, and they're predicting that there could be a complete massive growth for Python. Well, I don't want to mislead people into thinking that this is in test automation or anything. This is sort of just generally. This is mainly due to, I think, data science. Python is just seeing quite big growth, and because of it, there's quite a lot of benefits that can come to us as well. So why Python? Why not anything? Why not Java? Why not C#? The thing is there's no truly better language at all. And even if I was to say here and try and make an argument, I wouldn't be that good enough to be able to do it anyway. So it's all about context for you and your team. It's about your skills and what you're prepared to be able to do. It sounds a bit obvious. It's the skills of your team. It's about whether you want to kind of put your test co-located with your production code, for example, and that's kind of highly linked to the skills of your team. For example, if you're doing web front-end tests, and that's written in JavaScript, for example, maybe it might be better to write front-end test automation in JavaScript along with your test code. It's all about what the sort of tasks that you want to do in the available packages and libraries to be able to achieve what you want to achieve. The external support given to you when you need to be, help if you're learning, or even if you're an intermediate and you're trying to kind of pick things up. And it's also some of the design principles that you want to achieve. And this one, I'm hoping to give you a kind of a slightly unique perspective for Python, why you should maybe choose it. Some other reasons why Python I think is quite good is, generally I think there's a good lower barrier for entry to get into it. It's still quite a difficult language to learn later down the line, but I think it's much easier to kind of start off and get on that hump. It's open source, it's a scripted language, you don't have to compile it first and then run it. You can just create a file in Python, write your code, and then just go to a terminal and just run python in your file name and it'll just run. It's platform independent. It has a really large standard library for anything to do with math, and you don't have to go to external libraries. There's quite a lot in there built in. There's an extensive community set of packages on this thing called PyPy, which I'll go over very slightly in a minute. And there's a very, very vibrant and supportive community to help you. And realizing that I had these animations going. So, Just to give you a slight overview, again, I'm not really comparing to say Python's better than Java. It's just kind of illustrating the sort of low barrier for entry. In Java, it's an object-oriented language. Just to do something as straightforward as in print, I have to create my class, my main method to run the program, and then have this print statement. But in Python, I can just all do that in one line. And I ran the maths, and I'm pretty sure that 1 is less than 5. So you might want to do all sorts of things. You might want to automate browsers. You might want to do tests for automation apps. You might want to automate APIs. I'm conscious I'm standing in front of the screen for people here. You might want to run your tests in a distributed way. You want high concurrency, run your multiple tests at once to make your overall run quicker. You might want to do BDD. You might need to do some nice reporting to attach to, say, continuous integration runs to easily identify issues. It can all boil down to your fundamental framework that you're using. Some of all of these things could be packaged in with it, but generally, the test framework that can influence how you design your tests, which is probably one of the most critical things. So the most popular test frameworks out there at the moment, you've got unit test, which is the standard library, which is kind of based on the XUnit, JUnit style test classes. Another one, which I believe sells itself as an accept-as test-driven development framework called Robot Framework, not to be confused with Robotium. That's also quite popular. And then there's this one called Pytest. And Pytest is the one I'd like to go over today, because I think it's got some really powerful sort of features to be able to get you off the ground quite quickly and create quite concise and scalable tests. So has anyone used Pytest before? Ooh, so there's a lot of Pythoners, but not many people have used Pytest. That's good. Right, that's not good. Let's try and change that. So, a basic JUnit test. This is JUnit 5, but probably most people use JUnit 4 still, so there might be some slight differences. I realize that the lines on the screen probably don't help. But you create your test class, and if you want to run a test function or a test, you decorate your function with this @test, and then you compile and then run your test. And here I'm just doing assert equals 3 equals 3. To do the same test in Pytest, it's just 2 lines here. You write your file, test_file_example.py, then you've got your function name, and then you've got this assert 2 equals. I'm just testing that 2 equals 2. So again, the difference, there's not much kind of boilerplate to kind of get going. You just need to open the file and just bash out a couple of lines. So just going back to this file again, just some notable things. We've got this assert. We don't have to do the assert equals or anything like that, or assert between. I can just do this assert and put all that logic to the other side and put it there. There's another noticeable quick feature here that I'm putting a prefix on my test file and my test function with test underscore. And when I do that, Python knows when I'm running any sort of project that has loads of other files, it automatically picks up these files and these tests by that prefix. So that's a very, very, very simple test. To install Python, just to give you a quick brief overview of that, if you're already aware of Python and pip, then this is kind of straightforward. But for people who are not new to Python, there are a couple of things that you need to know, which I'll just go over very briefly. We've got 2 things. Python manages its packages, i.e. installing your dependencies and everything, by using something called pip, which I think has a few few names between it, but I think it stands for pip install packages. It's a nice, easy way. Just kind of think a little bit like Maven, a little bit like Ruby Gems. So you install it, it goes to the central PyPy somewhere on the cloud, and it comes back and it installs your package, and you're all good to go. And another thing I just want to mention that I think is really useful if you get off the ground in Python is something called virtual environments. Again, I'm not going to go too much into detail, but the rough idea is this. If you have multiple projects and you have different dependencies between those projects, you don't want to keep managing those dependencies on a global install. You'd like to switch between projects and keep your dependencies separate and easily work on your projects and switch between them. So for example, I've got 3 projects here. I've got a virtual environment that I create, and in that virtual environment it has a specific install of Python, and then it has its own packages that relate to that project. Same with the second project. Here you can notice I've got 2 different, say, custom library, and they have different versions. That might be quite important to you. So just to give you a kind of analogy, you might have say a web test repo, test iOS or API. you can create these virtual environments that keeps your dependencies separate so you don't have to keep managing between them. So that's a very ultra crash course in virtual environments, which is probably not enough to get you going, but please do be aware of virtual environments, and that's easy for you to kind of get going. So going back to this test, if I want to run this test, I've got this test and I want to run this test. How do I do it once I've installed it? Well, I just go to my terminal. I'm just assuming here that I'm also in my virtual environment. I have navigated to this folder where my test is, and then I just run Pytest on it, and it will find those tests given the prefix, and it'll give me some information, and it'll tell me here that it found test file example, and then it's put a dot next to it, which is just shorthand for pass. It'll put an F if it fails, and it gives you like a nice little breakdown. So let's extend this test a little bit. We've got a test file example. This time we are just putting a function with it, and I'm just representing what we call a helper, and this helper just returns you the number 3, so return the number 3. And then this test function runs, and then I'm asserting that 2 equals 3. And the call for the function at the bottom right here is the method call. What happens when the test runs is it goes to the test, it goes on the second line, it runs, it sees that the method call is there, it runs that, and then it asserts 2 equals 3. And then when you run it again, that should fail. So this is an example of a failure, and it gives you a kind of a nice summary of what happened in your failure and doing like a comparison for you. So there's a very kind of quick overview of 3 things. The first thing is does test auto discovery by the prefixes. You don't have to do much boilerplate to get going. And you've got detailed failure introspection, which I didn't give you too much of an example of, but believe me, it does have it, and there's good documentation on Pytest website about how it does detailed failure introspection, things like comparing strings and dictionaries and things like that. The main thing that I think is very useful about Pytest, particularly getting off the ground, is its implementation for test fixtures. It does this in a very kind of simple and modular way. And what's a test fixture? In a test, you want to do some verification, you want to do an assert on something, so that's kind of obvious. Before that, you need to really prod it to get it to do the thing that you want to do to assert on, so that's kind of calling that the exercise. And then you've got this thing around it which you need to set up your test, and then you need to do this thing after and tear it down. Like you're setting it up and then you tear it down. So I'm just calling this, like, that's part of your test function, but on the outside, your test fixtures. That's what test fixture is. So you're set up and you tear down. And Pytest has a really good way of doing this, or slightly unique way of doing it. So an example of a fixture in JUnit, we've got this kind of test class again. I've got a test down the bottom here, which is decorated at test. It does the same one as we did before, asserting that 3 equals 3. But this time, before each test, I've got this function here, which is decorated at before each. And that just returns me this, or puts the variable number 3 to the value of 3. And what will happen is when it comes to that test, it will firstly recognize that there is a before each decorated methods in the test class, and it will run that and then run the test. Quite straightforward. This is trying to do the same thing in Pytest. Now you'll notice that I've not got a test class, I've just got a test function. Python is, it supports functional programming, even though it isn't a functional programming language. It supports object-oriented programming. You've got all these kind of different options. Unlike in Java, I think it's just purely object-oriented. And in this case, I've got an import for Pytest. I've got this function called 3_fixture, and I'm decorating it with something called pytest.fixture, which in this method, it returns me the number 3. In this test function, you'll notice I'm doing the same assert, 3 equals 3, but I've got this thing down the bottom here as an argument of my test function, 3_fixture. What I'm doing here is I'm decorating a function with this Pytest fixture. This puts it in a library, almost in the background for Pytest, and it recognizes that by this unique name of 3_fixture, it can inject that fixture into any test function. So this is the fancy way of saying it is dependency injection. I've got this test function, and what will happen is it will get to that first line. It will get to the test function, it will read the test function, and before it even gets to that first line, it will recognize that it's got arguments in there. When it sees the argument, it will try to find that in the fixtures. It will see that there is a fixture exists, and it will run that first before it goes into the test. So let's just kind of look at a use case. And some of these use cases are pretty much exactly how we do them at FanDuel. So say we have an API test. We're testing against the API. And the methods that this API has, let's just for simple sake, we've got a login. We want to retrieve our username after we've logged in. I don't know why we want to do that. We want to give money to someone or something, and we want to log out. So the methods on the test, let's say we want to get username and give money. And the test setup in this case would be I want to log into the API or, instantiate the API and log in, and the teardown would be to log out. One thing I want to assume here, just kind of for brevity's sake, that I have already created an SDK that allows me to interact with the API. That might be something you're not familiar with. There are things like Swagger that lets you kind of create a library that allows you to interact with an API easily in Python as objects and methods. And let's assume in this case I've got data models for my user and that I've got already in my test environment, which is probably bad practice, there's already a user that I can use. And there's a reason why I'm doing that. So I've got a test fixture, pytest.fixture, and I've got this function called user, and it's returning me a user in our test environment, for example. And that user is Kyle McEvoy, and password 123. Please don't steal my password. There's a second fixture, which I'm going to break it down. It's quite complicated. I've got an API, which puts this user fixture inside a fixture, which I'll go over in a second. It's initializing an API client to somewhere locally. It's putting that client into a variable. I'm logging in with that client, and then it does some funkiness down here. But let's break it down. So say, firstly, if I wanted this test fixture, I'm doing something very simple. I've got an API function. I'm decorating pytest.fixture. I've got initializing an API client, and I'm returning that API client. But I want to return a logged-in API. Well, we already know that I've got a user from before, and I can inject that user dependency into the API fixture, and I can log in with that API using that user's credentials, and then returning the API client to the test. Then, we were talking about teardown earlier, and typically what happens, if I just go back, typically in a, say, JUnit, you can create a before and I believe it's like a teardown. I'm not sure what the decorator is. I think it's like after or after each. And you would put your teardown, maybe a log out of the API client there. With Pytest, we can actually put that in the same function and change the return to this yield, which means when this fixture is run, we'll initialize the API client, it'll log it in, and then it'll return this API client to the test function, and then the test will run, or each test will run, and at the finished, it will come back to this test function and then log out. So we've got a setup and a teardown in the same function. So to put that all together, in my test, I've got this fixture for a user, I've got this API fixture, the setup, and in my test, all I need to do is inject my API fixture into my test against the method getUsername, and then assert against the responses. These are very oversimplistic responses, but this gives you a sort of an idea of how you can inject these fixtures quite nicely. One thing you'll also note here is I'm only injecting the API fixture and not the user. It already knows that my user has been logged into the API. Let me give you another example here. By the way, this is just the same file, not doing anything else, but apart from just putting in the imports, just to kind of make it complete. You do have to do imports in Python. It's not magic. So the advantage of this, if I just take those fixtures again and then pull it to a different file, if I want to use it across different files, not just one file, then I can put it into this separate file called conftest, put my fixtures in there, and then if I have multiple test files that want to use the same setup, therefore I don't have to create a before, a decorated like before function in a test class for each test class across files, or do some sort of test inheritance, I can just inject this API fixture into multiple files. But not just multiple files. You can do it in multiple projects, which is also quite useful. So I've got a test here that tests my getUsername, and then I've got another one which tests the credit. Let's just say for our API test, we have we said that we had this test user already, but let's say that for our test, there's a really good setup that we actually want to create a new user every time for our test setup, rather than have one already created. So that test user, if you can imagine, just goes into that test setup now with the login. So I go back, I've got my fixtures, I've got my user, I've got my API test, I've not changed anything just yet. I've got my tests here, just as they were before. But this time, I say I've got a helper that creates me a random user in the test environment. Any username, I don't know what the username is, don't know what the password is, it just creates them. It does it organically in the system. What I can do then is in my test, if I do want to, which I was doing before, assert against a username which I thought I already knew, I don't know this username now, it's dynamic every time it's created, I can inject that user fixture into this other test function and then access that details of that text fixture. It's quite handy. And by the way, if I was to inject that test fixture into that fixture there, it's actually using the same user fixture as the API one is using. It's not creating a separate test fixture for that user. Another kind of fancy thing, this is where it starts to ramp up just a tiny little bit. You can do other things such as parameterization. You want to run the same test multiple times, but with different input values for something. It uses fixtures for that too. You have a test function. You mark your test, you decorate your test with this pytest.mark.parameterize. And then this bracket here, I name what my input variable will be to change. And on the right-hand side, I've got an array or a list of different values that I want to inject. So I'm testing here an invalid amount to give money to a user, a negative amount, and an amount with 3 decimal places. And I've injected that name, invalid underscore amount, into the test function alongside the API as an argument. And that will run, that's actually 2 tests. It'll run it once and then run it a second time. So, Pytest, this test auto discovery, it's got very little boilerplate, detailed failure introspection, and then we've got this kind of nice, simple modular way of doing test fixtures. There are also really good kind of complementary packages and plugins that you could use to kind of pull this all together to let you do all those things like browser automation and stuff like that. So popular plugins and packages for you to use. In the right-hand side are the actual names of them, so you can take notes and search for them on GitHub or anything like that. You've got the bindings for doing Selenium in Python. You've got a nice wrapper around the above in Pytest, which I'm going to give you a really good example of why you need those 2 things, or you don't need, but it's quite useful and handy. And you can do Appium, there's an Appium client, if you want to do mobile, native, packages for behavior-driven development BDD, and another really useful thing which we use, test distribution, allows you to run Pytest concurrently. So if you want to run it concurrently on your local machine, or you want to send your test to a Selenium grid or Source Labs or anything like that. With the test distribution as well, in Pytest, all you have to do once you install that, if you want to run multiple tests, you just run Pytest, then -n equals, and then the number of current threads you want to run. I keep forgetting how to do this. I've got these nice little animations going. So, Pytest Selenium. Assuming that you've got Chrome driver installed or any sort of web driver, these are the only things you need to do to get going to get a browser up. So you install this package, Pytest-Selenium, once you've got that in your virtual environment, scratch all the other things that I put on before, just create a new file, put a test function, inject an already built-in fixture from this called Selenium, and then just write one line, selenium.get, and then put your address in there. That's 2 lines, and you've already got a browser up, and it's gone somewhere. 2 lines is pretty good. And you run Pytest --driver Chrome, and I think it was 2 lines. I find that pretty amazing to kind of give that nice wrapper for you. I want to tell somebody about it. I'm down with my dank memes, so I just had to let everybody know that that's an iconic geo for me. So let's take another example with a browser test. Again, very similar to what we do with what space allows me on a screen. Imagine I've got a deposit page under test. I do a test setup, which I need to create a user. I need to load a browser. I need to log in as a user. I need to navigate to the deposit page. And then my teardown is to close the browser. given I know Pytest and I've got these fixtures, how do I get to this point? So, given that I have these test setups, I want to create a user, I can create a user fixture. Doesn't matter exactly what's in there. We've seen an example of that previously. We create a user fixture, it returns me a fixture. I know that we've got the Selenium fixture I showed you in that kind of two-liner, which I'm really enthusiastic about, and I can't stop telling you about it, is we've got the Selenium fixture and the user fixture. So I know I've got this thing that gets me a browser, and I know I've got a thing that gets me a user. The thing is, knowing that I can combine and kind of inject fixtures into fixtures, I can have this other fixture, which is a logged-in browser, which is I've got my Selenium instance and a user, therefore I can do extra logic to log in the user too, which means I've got an additional fixture called logged-in browser, which uses the user fixture in Selenium. So I've darkened these because whilst I need them, I don't need to inject those into my tests because logged-in browser already uses that. And I'll show you a practical example of that in a second. Let's just go further down this setup. If I've got a logged-in browser and the next thing I only need to do is navigate to the deposit page, then I maybe need a deposit page fixture to navigate to it. And if I needed a logged-in browser to be able to do that, then I can inject my logged-in browser into the deposit page. So my deposit page fixture uses a logged-in browser, which itself uses a Selenium and user fixture. That sounds quite a lot of information. Don't worry. I'm going to make it all clear very shortly. Then we've got this test teardown, which closes the browser. And by the way, you get that for free in the Selenium fixture as part of that yield. And then, the next step in the logic. So a bit of background. If you do like a, Selenium-based like automation against browsers, like a typical way of organizing your repository is doing something called designing page object models. We do that. So we create a page object model which has some functions which allow me to access items on the page or interact with it easily. I'm not going to go into too much detail about that. I'm kind of assuming that you already know part of that already. So this is just a very kind of, I put 3 dots here, like just kind of breaking down that we have this. But we wrap this around in a fixture to be able to access it easily. So I've got this contest file. I'm going to put all my fixtures in there. I've got a user fixture. It creates me a random user. I've got a logged-in browser fixture, which uses the Selenium fixture and the user fixture. It gets the base URL for our site, say FanDuel.com. We'll do some funkiness, which is we don't want to go through the login page every time we do a test. So we go to the API directly, make a call, get an XOR token, inject it in, so we don't have to go through those steps. If you've got a few tests, going through the login screen every time is probably a bit of a drag. And so then it returns that driver, or put it named as Selenium here. And then finally, I've got this deposit page fixture, which uses the logged-in browser. So it returns an initialization of the deposit page using the logged-in browser, and it loads it. So what does that look like in the test? Just this. I've got a test deposit page, I've got my test function, injecting the deposit page fixture, and then I can interact with that page. I've got a deposit amount of $10. I initialize like a card, an object for a card, for example. I select a custom amount to deposit, which is $10. I complete the form for my credit card, I submit deposit, and then I do assertions on messages, which is kind of doing like a little bit of UI, maybe like very straightforward UI on the form, happy path. You might want to, and I'm not sure why, but just can you give you an example of the sort of power with fixtures is if maybe I want to extend this test to also check the underlying system, not just the UI, that the deposit amount has changed and that I've got a successful deposit. This is where it gets a little bit heavier, a bit messier, but this time I'll highlight for you the differences. I'm injecting a user and say a user service, which is my microservice for users. I'm calling that service to get its user balance before I go into the test and make the deposit. So I'm checking actually at the service level. And then I'm making another call after I make the deposit in the system and comparing that the balance has changed. Giving you this gives you good power to start injecting in different places things for your test setups. You don't have to keep relying on each test class having its own setup. You just worry about the tests and inject it from a central place or central places. This way ramps up a little bit again. How am I doing for time? 5? Run out. Time over. Okay. Right. I totally overcut this, so just to kind of go over this example, I've got fixtures here. And what we do is we have multiple projects, and we have a common project which has all these fixtures which you can inject into, which is really useful for API projects, mobile, anything. All that underlined, you get really reliable fixtures for everything, any of your projects, which is really good. And just to thank you to Pytest, these are the books you can read. You can find these slides. I'm really sorry for overcutting this talk. I'll give you the quick slides here just so you can see and take a picture. And I will write the blog to kind of cover this to kind of make up for it. So I apologize for not getting these in. And yeah, thank you very much.
Thank you, Kyle. I think you can continue discussions over testing in Python during the coffee breaks or this evening. But let's take time for one question. Yes, there is a question.
Hello, thank you for the good presentation. I want to ask, I see that you used few asserts in one test. So if the first assert failed, the other will continue. Do you have some kind of...
It will not. It will fail at that first assertion.
Okay, so these two, which is Pytest, don't have such fancy asserts?
I think it actually does. I think it does, but by default it doesn't. And I can't recall off by heart.
Okay.
But I can find out for you and get that information.
Okay, and what about the report? It's good looking. You can show it to the managers and, I don't know, stakeholders, for example?
There is a reporting in the Pytest-Selenium package, if it was for Selenium, for example. That comes with a nice reporting facility which not only gives you the failure and the actual failure introspection, yes, that thing, you also get a screenshot with it as well at the point of failure.
Thank you.
Thank you.